Hi, calculus. We're on 3.4. We finally get to do derivatives. All right, this is fun, and there's a lot of different things derivatives do. I know this is the beginning, so you won't get to see it, but as the year goes on, you're going to love these. All right, let's go. First, we're going to calculate the equation of a tangent line, and then calculate the derivative for the function. So we've already found like the rate of change right here at this tangent line. Now we're actually going to create the equation for that tangent line is what we want to do. So remember the secant is the 2 points. So as the secant gets closer and closer and closer together, we get closer and closer to this tangent line. And a tangent can only touch the curve in one spot. If there is more than one tangent, then you can't find it. So here we go. Matches the curve slope as it exists. There is only one tangent line at a given point if it exists. So when you look through here, which one of these are tangent lines? Stop and circle them. Okay, the first ones I hope you found were P1, P3, and actually P4 is also, but we'll learn about him later. The ones that go through here and cross are not tangent lines. The tangents can only cross once at such a point, and they don't usually cross the other sections. Okay, we're going to start by using our same limit formula. So we're going to do the a plus h minus the f of a over the h. All right, this is going to give us our slope. Okay, when we plug the number into the original, we're going to get our point, and we're going to write 0.4, our point slope form of the line. Okay, then we're going to do derivatives and calculate the derivative of this here. And let's get moving. Okay, let's find the derivative of f of x, x squared. To do this, now remember this is the same as the other one, except now h approaches 0. So we do f of x plus h, so we plug that in first, and we get x squared plus 2x plus h. We're going to subtract our original, so we're taking, this here is our f of x plus h minus our f of x, is what we've done here. Cancel these out. Then we have to divide this by h. And once we divide that by h, now as h approaches 0, this disappears, and we're left with 2x. All right, so this is a limit as h approaches 0. So next, use the derivative to find the tangent lines at a certain point, so x equals 3. So the first step is we plug 3 into the original. So this is the original problem before you've done anything. So you plug in 3 to our x squared, and we get 9. So our point is 3, 9. Now we plug in 3 to our derivative that we found up here. So we get 2 times 3, and our slope is 6. Now we just write the equation in point slope form because we're given a point in the slope. So it's y minus y, which is the 9, equals the slope times x minus x. Distribute and dissolve if you would like. If they don't ask you what form you want it in, this is fine. This is how the book leaves your answers, though. They always change it into slope intercept. Okay, let's go first. First, we have to find the, oh, pause. I guess it's your turn. I was going to show you how. Pause and give it a shot. All right, your first step, you should have found f of x plus h. So when you did that, you got 2 times x plus h cubed plus 4 times x plus h. If you remember that a cube goes 1, 3, 3, 1 for your coefficients, you can use that. If not, you should be taking x plus 3 times itself 3 times, right? So take these two, multiply them, then multiply them by this. I'm going to use the 1, 3, 3, 1. So this goes to 2, and it starts like this. So this is x cubed plus 3, x goes down, h goes up, plus 3, x exponent goes down, h goes up, plus 1h cubed. If you remember that, it's from your binomial theorem, plus 4x plus 4h. So this here is a total of 2x cubed plus 6x squared h plus 6xh squared plus h cubed plus 4x plus 4h. That's your f of xh. Now you have to subtract your f of x. So I'm going to subtract your original. I'm just going to line these up. So I'm going to subtract the 2x cubed and the 4x away. So this is going to disappear. This is going to disappear. We have 6x squared h plus 6xh squared plus h cubed plus 4h divided by h. So now we got 6x squared plus 6xh plus h squared plus 4. Now you're finding the limit as h approaches 0. So this guy's going to disappear, and this guy is going to disappear. And you now have your formula, which is 6x squared plus 4. All right, find the tangent line at x equals 2. So step 1, we plug the 2 into the original. So it's 2 times 2 cubed plus 4 times 2. Type that in your calculator and you get 24. So your point is 2, 24. Now we got to find our slope, which is, I always write that f prime of 2. So our first derivative is how this is read. We're going to plug this into here. So we're going to get 6 times 2 squared plus 4. Plug that in your calculator and you get 28. And this is your slope. Now your equation of a line, y minus 24 equals to 28 times x minus 2. And you may solve further if you wish. I hope you did well. All right. Now, derivatives when they're a little bit ugly. Hey, are you ready? Now, we still have to do the same thing, the x plus h minus the f of x. So let's do f of x plus h. That's equal to 4 over x plus h. Then I have to subtract our f of x. So I get 4 over x plus h minus 4x, my original, all over h. And I need to find the limit as h approaches 0. Okay, when we're looking at this, this is not pretty. So I'm hoping you remember how to find a common denominator. So I need to find a common between all of them. So this guy needs an x. This guy needs an x plus h. And this one needs all of them. All right, so in my numerator, I'm going to have 4x minus 4x, I'm going to distribute, minus 4h all over h times x plus h. Well, these two cancel. So now I've got minus 4h all over h times x plus h. These h's cancel. I have negative 4 over x times x plus h. Well, as h approaches 0, this becomes x. So my final answer is negative 4 over x squared, your first derivative. So the equation, the tangent line at x equals 2. So first we have to do the original. So f of 2 is going to equal 4 over 2, which equals 2. And then f prime of 2 is going to equal negative 4 over 2 squared, which is 4, which is going to be negative 1. So your equation of your line is going to be y, here's your point, 2 comma 2, don't forget, minus 2 is equal to negative 1 times x minus 2. Equation of your tangent. All right, try yours. See how you do with this, dude. So now you have to find f of x plus h. Well, this is going to be the square root of x plus h plus 40. We have to subtract our original, square root of x. I'm just going to distribute my negative all the way through. Then I have to divide by h. All right, what are we going to do with this thing? Well, the 40s cancel, which is awesome. But this gives us the square root of x plus h minus the square root of x over h. I have no idea where to go. That just looks like a mess. Well, I can't do anything with the denominator. I can't cancel in the numerator. So let's try getting rid of these square roots. Remember that conjugate thing? It might come in handy here. Square root of x plus h plus the square root of x. But whatever you do to the numerator, you got to do to the denominator. All right, well, my numerator is going to become x plus h minus x all over h times the square root of x plus h plus the square root of x. Well, the x's cancel. H is going to reduce to 1. So now we've got 1 over the square root of x plus h plus the square root of x. Well, as x approaches 0, this is the square root of x. So now we got 1 over 2 square roots of x. Interesting. First derivative, huh? Kind of cool. All right, tangent line. So the tangent line is at x equals 9, so we're going to plug 9 into the original. So you have to do f of 9. So you've got the square root of 9 plus 40, which equals 43. Now you have to do your first derivative of 9, which is equal to 1 over 2 times the square root of 9, which equals 1/6. So remember, oh, that went away. 40, there it goes, 43. So this point is 9 comma 43. Your equation, y minus 43 equals 1/6 times x minus 9. All right, I'm hoping you're noticing something here as you're going through. There's a shortcut to derivatives, and let me show you. If you look, 6x squared plus 4, how could I use this to get to 6x squared plus 4? Well, if you notice, if you take the exponent times the coefficient, you get 6x and subtract 1 from the exponent is squared. So this one here is 1 times 4. Hard to see. So you take the 3 times the 2 and subtract 1. 6x squared. 1 times the 4. Subtract 1 makes 0. 6x squared plus 4. First derivative. Now let's go down here. See if it works when it's ugly. Whoops. Here we go. Now, in order to do this one, first you have to get the exponent in the right place. So we're going to call this f of x equals 4x to the negative 1. Okay, so multiply. Negative 4x, subtract 1 to the negative 2, which equals negative 4 over x squared. First derivative. Okay, is that what we had? Looks pretty familiar, right? Okay, try your shortcut and see if you can get it. So the first step is you take f of x and you write this as an exponent. So you have x to the 1/2 power plus 40. So now this becomes, so your first derivative, bring the 1/2 down, x to the negative 1/2 power. 40 has none, so it goes away. Negative 1/2 means it's in the denominator, so it's 1 over 2 square root of x. Kind of a cool little shortcut, huh? Now that you know how it works, you can use them all the time. Okay, difference quotient, derivative. Derivative just is said it has as it approaches 0. Derivative finds velocity, instantaneous rate of change. This finds average rate of change and average velocity. Okay, next step we need to go through. Tangent line does not exist. That exists when you can draw more than one line through it. Now, if you look here, I can draw a line pointing there, or here, or here. So this does not have a tangent line or a derivative at 0, is what that means. So no derivatives exist. This one, technically, right here, the tangent line is vertical. So the slope of this thing is undefined, correct? So that means you don't have a derivative either, even though it is just undefined. So let's go through and look. These is all good. I can draw a tangent. I cannot draw one here, and I can draw one here. I can draw multiple. The same is true here. So also no tangent. Same here. Cannot draw a tangent. This here you cannot draw a tangent because it goes on forever, so it doesn't have a value. This one here has a tangent. It's a vertical, so its slope is undefined. If it's open, it does not have a tangent because there's no point to draw through. Okay. Continuous. It's a smooth curve, so it doesn't have your sharp edges and does not have a vertical tangent line. All right, so it does have a derivative. If it does not have a derivative, if it's discontinuous, sharp corners, or has a vertical tangent line. All right, that's all for your notes. I hope you're doing well. I love derivatives, and you can use your shortcut every time if you would prefer. Have a great day, and good luck on your homework. Don't forget to post your questions.